Good day, everyone. You're welcome to my channel. This time around, we are considering alternative to practical in physics. When we are looking at alternative to practical, this is the type of practical that we normally have in an examination such as GCE and NECO-GCE, and also in our Cambridge IGCSE, we have alternative to practical. Uh, so, what is alternative to practical itself? Alternative to practical is just the way it's just a description, or let me say, what describes how practical is performed in the laboratory. Now, what makes alternative to practical different from our real practical? Unlike the normal laboratory practical, in alternative to practical, our observations are represented or illustrated on figures and diagrams. So, in alternative to practicals, we always take our observations from figures and diagrams. So, how do we do this? That is what we are going to be looking at in this video. But before we continue, please, if you are yet to subscribe to this channel, please do, so that you have access to any of our video whenever we upload them, and also you help us to keep the channel alive as well. Okay, let's start with the first question that we have here, the first practice exercise that we have here. This video is very important for those students that will be writing GCE and NECO-GCE, or the student that choose to write alternative to practical in Cambridge IGCSE examination. Okay, let's look at what we have here. The resistivity of material. We can see the circuit diagram. In the circuit diagram, we have the rheostat, we have the fuse, we have the ammeter, and we also have our uh, source of potential difference. Okay, now this is our rheostat, this is our fuse, and this is our ammeter, and we also have a source of potential difference as well. Okay, now let's look at the information about this particular practical. In this one, we have a circuit connected. As shown above, you can see the circuit connection here. Okay, and in this circuit, we have to investigate the dependence of fusing current on the diameter of the wire of the fuse. Okay, if as you can see, this is fused, and from normal description, fuse used to have a wire, and fuse is a sacrificial element that when current passes through it, when the current is too high for the circuit, the wire will cut off so that the circuit will be protected. And we all know the function of a rheostat in a circuit. Rheostat controls the flow of current in the circuit, while ammeters measures the current that is flowing through the circuit, and the source of potential difference is the source producing the current as well. Moving away from this, okay, now according to the illustration here, a wire of known diameter is placed in the fuse box that you can see in the fuse box. In the circuit, we have a wire of known diameter placed there. Okay, now, and the key K is closed. The rheostat is adjusted to increase the current until the wire melts. Like I mentioned, rheostat is used to control the current, now thereby breaking the circuit. And the current I subscript A, which melt the wire, is read and recorded on the ammeter. So this entire procedure is repeated with another wire of the same material and the same diameter, and the fusing current IB is measured and recorded, and the mean fusing current I, which is equal to the half of the sum of IA and IB, is determined and recorded. This is the procedure that is to be followed in this experiment. Okay, now the whole experiment is repeated with 4 other wires of the same material but different diameters. Now we now have the information, because this is alternative to practical. It's not the practical we are performing in the laboratory by ourselves. So we have a figure 1b, that is from figure 1 to 5, shows the scale diagram of the diameter di of the wires used, while figure 1c and d shows the set of ammeter readings IA and IB. So what are we going to do with all these figures? Let's quickly look at the figures here. Now you can see the figure 1b. You can see the diagram here. We have a Roman figure 1, Roman figure 2, 3. We have a Roman figure 5, Roman figure 5. All this one represents the diameter of wire varies in the fuse box. And we have a figure 1C and 1D, which represents the current that we have on our ammeter during this experiment. Okay, what are we to do with these ones? Okay, according to this experiment, we have to measure and record the real diameter of the wire using the given scale in that figure, and we have to read and record the corresponding IA and IB, and we have to evaluate I. Remember, I is to be evaluated using this formula here. You have to evaluate using this formula. Okay, let's move away from this. Let's quickly go to the figures and see how we can it is now. When you come to this, like I said at the beginning, we are to use the figure given to get our observations. Now, what they expect us to do here is to use our ruler to measure the diameter. And how do you do this? Okay, you put your ruler, the zero mark on your ruler at this point, and you measure across this line. So D1 represents the diameter of the first wire used in the fuse box. So we are going to record this in centimeter. Now please, as you can see on the scale, we have 1 centimeter representing 0.5 millimeter here, please. So when you are dealing with something like this, please, you are advised to use a ruler that is calibrated in centimeter, after which you are going to convert whatever you measure into millimeter. So by doing this, you measure from here to this place, you record in centimeter, do the same thing to this, do the same thing to this, and these are the variables that you are going to have for D on your table. Now, after measuring this diameter in centimeter, and you have this scale that is 1 centimeter representing 0.5 millimeter, that is for every 1 centimeter that you measure, you have to convert it to 0.5 millimeter. So how do you do this? Let's quickly look at the sample of the table that we have on this. Okay, you can see from the table, this is the value of our D in centimeter. That is when we measure the value of our D in centimeter. The first one is 2 centimeter, the second one 2.4, the third one 2.75, we have 3.1 and 3.6. Now all these are to be converted to millimeter, and that is what we did here. So on your table, you have to first show the real value with the corresponding unit. Now, like our normal practical, we present the table of our alternative to practical the same way we present the table for our normal practical. And if you don't know how to do that, please check on one of the videos that we've uploaded on this channel, that is NECO 2023 Physics Practical Tips. It's on this channel as well. Everything about how to present your table, how to draw your graph, how to calculate your slope, your intercept, and even precaution, everything about that is there, and it is the same for alternative to practical. You have to have a composite table like the one you can see on the screen here. Okay, we measure the diameter in centimeter and we converted it to millimeter. How do we do this? Remember, according to the scale on the diagram, every 1 centimeter is to be converted to 0.5 millimeter. So which means that whatever that we measure here, we multiply them with 0.5, and that is what gives us what we have here. So that is what we did on this table. Okay, what else do we do? We also have a figure showing the value of the current IA and IB. This is the figure showing the value of current IA, while the figure here is showing the value of current IB. And if you look through this very well, let's look at them. Now, to read this is very, very simple. Look at here. This is 0, this is 6, and this is 12, which means from here to here, we represent 1, we have 2 here, 3, 4, 5, and this will be 6, like that. So if you look at this very well, from here to here is 1, it is easier for us to just determine the value of each calibration, which means each of this calibration stands for 0.2. Each of this calibration stands for 0.2 ampere, and that will help us to read what we have here. Each of the calibration will stand for 0.2 ampere if you read the calibrations very well. And with this, we are able to take the readings of our current. Now, let's quickly go back to that table. And as you can see on the table, this column represents the serial number of your experiment, that is the number of times you perform the experiment. And if you look at this place represents the current read from the figure 1C, that is the current value read from the figure 1C, and this is the current value read from the figure 1D. Bringing them together, we're able to find the value of I, which is equal to half of the sum of IA and IB. Remember, at the top of this table, at the top of each column, we have the quantity measured and the unit there. So you are not meant to record the unit in front of each value. It is very wrong to do this. So that's why we have the unit written in front of each quantity that we measured, and this is applicable for all practicals. So you can see the unit, and this table that you are seeing on your screen, it's what is known as a composite table. And having this, you are going to have your complete mark for the observation. And similar to our normal practical, alternative to practical also, as a each experiment you'll be given 3 in your GCE and NECO-GCE. You'll be given 3 questions you have to answer to. Each of the question is equal to 25 marks. So the marks for, if you can present your table, your composite table in this form, you are going to have your complete mark for your observation. And also study when you are reading the question, the procedure to follow. Always check for the constant. If you have any constant, you have to record them at the top of the table before drawing your table. Record your constant with their corresponding unit. But if you don't have any constant, you can move on and draw your table. Okay, let's consider another example here. This one is talking about a moment of force about a point. You can see the diagram on the screen. So you can see a mass 100 gram is attached to 95 centimeter mark of the uniform meter rule, and it is maintained in this position throughout the experiment. What does that tell us? That one is telling us that this mass 100 gram is a constant in this experiment, and the position this mass will be, because it will maintain that position throughout the experiment. It means that position can be recorded as one of our constants as well. Okay, we have another mass M, which is hung at this spot. It's hung at a distance Q from 0 centimeter mark of the meter rule, and the whole arrangement was balanced horizontally on knife edge as shown above, and the distance P is measured and recorded. If you are familiar with this type of experiment, you will know what we are talking about here. Okay, now the procedures was repeated for 4 other values of Q. That is, the value of Q is varied throughout the experiment 4 other times, and we balance the entire setup on the knife edge, and we are to take the records of the Q, the value of the Q, and also the P. Okay, now how are we going to do this? Like I said, alternative to practical, we use figures and diagrams to take our observations. Okay, now figure 2b shows the distance Q, that is the distance that was varied for mass M from 0 centimeter mark of the meter rule, while figure 2c shows the distance Pi, that is the distance of the pivot from 0 centimeter mark every time we varies the value of Q. Now, this I represents our serial number of the experiment. So, what are the instructions given to us? We are to measure and record the value of Q and corresponding value of P. So, in each case, we have to find T, which is equal to 95 minus P, and R, which is equal to P minus Q. Let's quickly check the figures that we are to use. Okay, we have the figures here, and also we have the table. Okay, as you can see, we are measuring the value of Q from the first figure here, and that of P from the second figure. And you can see that we are to start measuring the value of Q from 0 centimeter mark here. Okay, take note of that. Don't measure from the other side because 0 centimeter mark is written here. Okay, again, you pick up your ruler. As you can see, the scale 1 centimeter represents 3 centimeter. I would advise that you use a ruler that is graduated in centimeter also. So for the first value of Q, as you can see, I represent our serial number. So for the first value of Q, we have to measure from this zero mark to this first value of Q here, and whatever we have here, that is the first value of Q, and that is what we have on this table, and that is 5 centimeter. Okay, we did the same thing by measuring from here to this point for the second value of Q, and that is 7.6 centimeter. And similarly, we took the value of Q3, Q4, and Q5, and according to the scale, every 1 centimeter is to be converted to 3 centimeter. What are we going to do? What we are going to do is to just multiply whatever we have here, by 3. So that is the meaning of that. That is 1 centimeter represent 3 centimeter. So the 5 centimeter will be equal to 15 centimeter. That is what we have here. So I will advise, always record the real value before you show the converted value. It is very, very important. Always record the real value that you first measured before you now show the converted value, because some students, they will just jump the real value and go to the converted value. It is not done that way. Always record the real value before you show the converted value, and show the corresponding unit for each of them. Okay, let's go back to the second diagram where the value of P is written. Okay, for the value of P, why do we need to do this again? Okay, look at the value of P. For the diagram representing P, you can see from this diagram, we have a damaged part. You can have a diagram like that. What they are telling you is that from this point to this point is measured to be 60 centimeter. So which means if you are taking any measurement on this, you have to put that into consideration. That is, by the time you are measuring the value of P1 from here to here, whatever you measure from here to here, you are to add it to 60 centimeter. That is the meaning of that. That is, we have initial value of 60 centimeter from here to this point. So that is what we are saying. So you quickly pick your ruler calibrated in centimeter, measure from here to here. So whatever you have, from here to here, so whatever you have to add it to 60, and that is what we did here. It means from this point to this point, we have a 2.4. Adding that to the 60 that we have here, we have 62.4. We did the same thing for P2. We measure from here to here for P2, and we have 5.2. Adding that to 60 centimeter, that is what gives us a 65.2. Similarly to P3, P4, and P5, every measurement taken from this part. So we add every value measured to 60 centimeter, and that is what is giving us the value of P here. And there's no scale to convert that, so we just leave it like that, and we evaluate every other things that we have to do here. T equal to 95 minus P, that is 95 minus every other value here, that is what represents T. Okay, and our R equal to P minus Q. Please take note of this when you are dealing with this. Now, once you've converted the value like we did to Q here, we've converted the value of Q from original value to this. Now, at that point, whenever you have to use Q again, you have to use the converted value. Take note of that. You have to use the converted value. Like in the case of R, you have to subtract the value of converted value of Q from P. That is what you have to do, because you've converted it already. Don't touch this again because you've converted it. This will be used in all your further evaluations, and even on your graph you have to use the converted value. That is what we did here. And after this, you can go ahead and plot any graph they ask you to plot. Follow the same way you normally plot your graph. Calculate your gradient, calculate your intercept, and present every other thing that you have to present. Okay, let's look at one more example before we call it a day. Okay, in the third example, we have refraction through glass prism. You can see the diagram. You can see the incident angle represented with I. You can see another angle represented with theta. So we have distance BC and we have distance AC. These are the things they will ask us to measure here. Okay, we have all our story that has to do with this, and we have okay, in this setup above, PQRS represent the outline of the prism with angle DAN equal to I, that is incident angle. We fix 2 pins on the incident ray, and the image will trace through the glass prism and every other thing. If you are familiar with rectangular glass prism, you will know what we are talking about here. Okay, now how do we now take our observation? We are to they repeated the procedure for other values for I, and that is shown in the figure 3b. So we are to read and record distance AC, we are to read BC, record the value of theta, we are to evaluate this, and this one represent this. So that is this equal to BC divided by AC. Okay, let's quickly look at the figure, what we have on the figure. Okay, now from the figure, when you are to measure any value, if it is a linear value, you have to use your meter rule. Like the value of AC, you put your 0 centimeter mark of the ruler here, measure along this part, that is your AC for each of them. For the first value of AC, you measure along this part. For your second value of AC, you measure along this part. Third value, you measure along this part. Similarly, fourth value along this part and this part, with using your centimeter calibrated meter rule. For your BC value, measure along this part. For the first value, you have this. For the second value, you measure from here to here. For the third value, you measure from here to here. For the fourth value, you measure from here to here. And for the fifth value, you measure from here to here. Now, you can see the value of theta. Theta represents angle, so you have to use protractor to measure your theta. And the 0 mark of your protractor is to be on this line. It's to be on this line, and you start taking your reading from here towards this direction like this. So that is how you do it. So putting your protractor on this line, you are to measure the value of theta 5. So you can start with theta 1. If you put your protractor on this line, measure your theta 1 value. And in doing that, we are able to have the values on this table. The AC is measured in centimeter, and we don't really have any scale for that, so you have to leave it like that. No, we don't need any conversion. BC is also measured in centimeter. We also evaluate mu, which is equal to BC divided by AC, that is this divided by this, and that is what will give us this. Okay, and we measure our theta using protractor, and we have the value of our theta recorded here using protractor, and we evaluated cos theta. You can go ahead and plot whatever graph you are asked to plot. Okay, now one other thing that I would like to talk about is the precaution of alternative to practical. It's a bit different from the precaution of our real practical. For example, in this particular one, you are to state 2 precautions that are necessary to ensure accurate result when performing this experiment. That is, when you'll be performing this experiment, or if you are asked to perform this experiment, what are the precautions? So you can see the statement here: I will ensure that the pins are vertically erected. Remember, if you perform the experiment yourself in the real experiment, you will state that I ensured that the pins were vertically erected. But in this case, you may be asked to perform the experiment. You've not done that already, so you can state your precaution in this form: that I will ensure that pins are vertically erected. That is, when you are performing it, you will ensure that. Also, you will ensure neat traces. But remember, when you are asked to state precaution for alternative to practical, you are not to state precaution on the figure given. Your precaution is not about this figure given here. No, The precaution is about the real experiment. Like I said at the beginning, alternative to practical describes how experiment is carried out in the laboratory. So when you have to state precaution on, for example, this type of experiment that is refractive index of the glass prism, you have to state the precaution that has to do with refractive index of the glass prism in the laboratory. And we have the sample here. That is what we have here. Let's quickly look at others. Okay, before we move on, you can see for this one, you avoided drought. I will avoid drought. But in case of real practical, you say I avoided drought because you've performed it already before stating the precaution. But this time around, if you are to perform it, I will avoid parallax error while reading the meter rule. Okay. Also, you can check the precaution for the first experiment. Okay. With that, we come to the end of explanation on alternative to practical. But if you still want to have more practice exercises, you can get a copy of this book that is displayed on the screen, the Fan Physics Practical Book. The book has a lot of practices on alternative to practical for GCE candidate, NECO-GCE candidate, and even Cambridge IGCSE candidates. Also, the book also contains a lot of practical exercises for real experiment in the laboratory. Just get a copy of this book. The book is Teach Yourself copy. If you have this book, everything about practical physics is already in this book. You will know how to carry out your experiment at the right time and how to report your experiment. Everything that you need to know about practical physics is in this book. Just get a copy of this book, and to do that, you have the contacts below. You can contact any of this number via WhatsApp or through call or this email address. Or if you choose to have the soft copy, you can easily get that on Amazon. Just click on this link for the soft copy of the book. And if you have any question on this video or anything that we've said that we've discussed so far in this video, the comment section is open for everyone to comment. So drop your question in the comment section and your question will be attended to. And once again, before I close this chapter, if you are yet to subscribe to our channel, please do, so that you have access to our subsequent video whenever we release them. And also you can help us to keep this channel alive. Thanks for watching.